Okay, so we're going to be talking about trigonometric equations. So trigonometric equations are, well, they're equations with trigonometric terms in them. So, for example, if I look at something like, I have an equation like 3 sine of x minus 2 equals 5 sine of x minus 1. So I want to get all the sine terms to one side. Well, what I can do is I can subtract 5 sine of x from both sides. And then I want to get all the numerical terms on the other side. So I add 2 to both sides. So that's going to give me negative 2 sine of x equals 1. Well, now I got to divide by negative 2 to both sides. So sine of x is equal to negative 1/2. So now there's two things I got to figure out here. The first is I have to know the reference angle. So where does sine of x equal 1/2? Well, sine of x equals 1/2 at pi over 6. The other part is, well, I have to look at, okay, well, where is sine negative? Well, I have to look at the quadrants. All students take calculus. So where is sine negative? The third quadrant and the fourth quadrant. So I had to know, okay, what are the exact values for where, sine gives me negative 1/2. So for this, it's just going to be my reference angle plus pi, which winds up giving me 7/6 pi. And then for the fourth quadrant, go around again. It's going to be not quite 2 pi. So that means it's going to have to be 2 pi minus pi over 6, which gives me 11 pi over 6. So there's more to it than that because that's only one solution for each of the quadrants, so total 2 solutions. But I want to know for all solutions, all possible solutions. So that means, for instance, for the first one, I would have x equals 7/6 pi plus 2 pi n. This part right here is extremely important because, see, the 2 pi, well, that's the period. The period of sine of x is always 2 pi. And n is an integer. So, n could be -2, -1, 0, 1, 2, ... in both directions. Then similarly, my other solution would be 11/6 pi plus 2 pi n again, but once again, n is an integer. So on, go on forever in both directions, negative and positive. So therefore, the solutions to this equation is x equals 7/6 pi plus 2 pi n, and x equals 11/6 pi plus 2 pi n, where, once again, where n is an integer. And that is the solution to this, and that's for this type of trigonometric problem. Now, another one you may come across is, another type of problem, for example, is something along the lines of, okay, you have tangent of 3x equals 1. But now, this time, it's on an interval where it's from 0 less than or equal to x less than 2 pi. Or an interval notation, that's just going to be bracket 0, comma, 2 pi, parentheses. So just a quick recap, interval notation. If you have brackets, that number is included. If you have parentheses, that number is not included. So again, it's from 0 to less than 2 pi. Again, less than 2 pi. So if I look here, well, I have to solve this equation. So basically, I had to look at, okay, well, where does tangent equal 1 at? Well, tangent's going to equal 1 in 2 quadrants. All right, again, all students take calculus. So where is tangent positive? Well, the first quadrant and the third. So I know tangent equals 1 at pi over 4. So I'm going to have 3x, not x, because I have a 3 attached to the x here. 3x is going to equal pi over 4 plus pi n, because the period of a tan x function is pi n, where n is an integer. And then the other value for where tangent equals 1, quadrant 3, which is going to be pi over 4 plus pi. And pi over 4 plus pi is 5/4 pi plus pi n. Where again, n is any integer. It's always integers for n. So now I have to solve for x here. I have a 3 there. Well, what can I do? Yeah, I could divide everything by 3, but to make it easier, using some algebra, multiply by the reciprocal. So multiply by 1/3 of both sides, distribute that throughout, and that winds up giving me x equals pi over 12 plus 1/3 pi n. And do the same thing for here. All right, multiply by 1/3, distribute that throughout. That gives me x equals 5/12 pi plus 1/3 pi n. So now, okay, since we're on an interval here, we can't just say, oh, this is the solution, here, what I have here and here. No, because it's a condition. It's on an interval. So we have to find values that satisfy both of these. So basically what I do, one way to do it is you make a table of n values versus x values. So for instance, I can't have -1 for n for the first equation, because that would give me negative pi over 3 plus pi over 12, which winds up giving me negative 1/4 pi. So that doesn't do it because, well, that's less than 0. So then I could start with, n equals 0. So that would give me pi over 12. All right. And then Look at the second equation. If I try to do -1 here, will that work? Well, let's see. If n is -1, that'd be 5 pi over 12 minus pi over 3, which winds up giving me 5 pi over 12 minus 4 pi over 12, which is pi over 12, the same thing as here. But if I plug in 0 here, I get 5/12 pi. Now, what about if I try for 1? Well, in the first equation here, I plug in 1. You get pi over 12 plus pi over 3, which is going to be 4 pi over 12 plus pi over 12, 5 pi over 12, same thing. But I plug in 1 into here, that's going to give me 5 pi over 12 plus pi over 3. And that would wind up giving me 4 pi over 12, 9 pi over 12, which winds up being 3/4 pi. And basically what you have to do, you just have to keep doing this until you get all of the solutions that are between 0 and 2 pi. So what winds up happening is you plug in 2 for n, you get, uh, well, 3 pi over 4, but if we do 3, if n is 3, you get 13 pi over 12. If n is 4, you get 17 pi over 12. And if n were to equal 5, x equals 7 pi over 4. So therefore, the solutions to this equation are pi over 12, 5 pi over 12, 3/4 pi, 13 pi over 12, 17 pi over 12, and 7/4 pi. And that is a solution to this equation. And if you notice, there's a lot of solutions we have here. We have 1, 2, 3, 4, 5, 6 solutions. So that's why it's very important that you check all the possible values, because these are usually trigonometric equations have multiple solutions. And that is going to do it for today. Take care, everybody. See you next time.